In the last video, hopefully you saw a text lecture and loaded in all the data that was contained inside that lecture. So we are now working with a database that has a very different schema. We now have a table of users, a table of orders, and a table of products. This database is going to kind of simulate an e-commerce application. So a user can order a product. One thing that we're going to investigate is the relationship between users and products. You're going to learn that this is a many-to-many relationship. One user can have many products, and one product can have many users. We are modeling that relationship by using the orders table. We would refer to this table in this case as a join table. Now, enough of all that. I'm going to tell you a lot about many-to-many relationships in just a little bit. I just want to give you a very quick preview. Right now, let's investigate the structure of these tables a little bit more. So I would encourage you to maybe do a select star from users and take a look at some of the different properties and values inside of here. So it looks like users has ID, first name, and last name. We can do the same for about products. And we'll see that products has ID, name, a department, a price, and a weight. The weight presumably here is maybe the weight of the product in kilograms, and it's probably listed here for maybe shipping purposes or something like that. The price doesn't seem to have any units tied to it. We can imagine that's maybe it is US dollars or something similar. In total, there are about 100 products inside of here. And then finally, we'll take a look at orders. An order represents a user attempting to order or purchase a product. So orders has an ID for the order itself. It has the ID of the user who is attempting to purchase a product, the ID of the product that the user is trying to purchase, and then finally, whether or not the user has paid for their order yet. So if a user has not paid, we would see false inside of here. And once a user has paid, we should see true. Okay, so 3 tables. We're going to take a look at some more topics and interesting ideas in the world of SQL in just a little bit. But first, let's do a little bit of a recap on some of the different topics we've learned in this course already. So we're going to run a couple of queries on these 3 tables over a couple of different exercises, just as a quick review on stuff like group by, selecting, joins, and so on. So quick pause right here, and let's take a look at our first exercise in just a moment. Let's take a look at our first exercise that we're going to use to get a review on everything we've learned up to this point and better understand this new e-commerce data set. The first exercise, our goal is to write a query to print the number of paid and unpaid orders. So the result is going to look like something like this right here, a very small table that has 2 columns and just 2 rows. So in this case, we would interpret these results as saying that there are 4 orders that are paid and 2 orders that are not paid. Now I've got some hints on here. Go ahead and take a glance at the hints if you'd like. And for reference, I've got the structure of the orders table in here as well. Now just as a reminder, in general, the data set inside these exercises is much smaller. So inside this exercise environment, there's only about 6 orders total. In the data set that you just loaded into your pg-sql.com environment, however, there are about 500 or something like that different orders. So you're going to find that there's a very different data set in both these locations, but the structure of the data set is identical. All right, so like the hints say, I really recommend you consider maybe making use of group by and maybe count as well. So go ahead and give this exercise a shot, and we'll go over a solution in just a moment. All right, let's take a look at a quick solution. Now first, I'm going to go through a diagram solution just to make sure the ultimate goal here is super clear. So here is our table of orders. We really only need our orders in this case because we are really just trying to count up the unique values inside this paid column. So we're going to do a group by on orders. So here's our kind of imaginary fake table over here. We're going to group by the paid column. So step number 1 is for our database to go through that column and find all the different unique values. In this case, the only unique values are true and false. Then we're going to assign each of these different rows to the appropriate group. It looks like this first one would go into true. We've then got a true, got a false, a true, and a false. So we've now assigned each of these different rows into one of these different groups. Now to get the number of rows in each of these groups, we could do a count star. So if we do a count star, that will count up the number of rows in this group and this group. So we would end up with a 3 right there and a 2 right there. Now the data that I'm showing inside this diagram is slightly different than the data that is actually inside the exercise. So you probably have something more like 4 and 2 if you got the correct answer. Either way, totally fine. All right, let's try actually coding this up then. So I would do a select paid and count star from orders, and I would group these by the values inside of paid. And that's it. So group by paid is going to do the grouping operation. We're taking all the rows from orders, and then we're going to print out the value of paid. And for each of those 2 buckets, we're going to print out the number of rows in each of them. As a quick reminder, we are only trying to print out columns, in this case, that we've grouped by or that are using a function aggregator. So we are not trying to print out any of these interior columns. If we did, we would end up with an error. Okay, so this looks good. Let's check our solution. Looks good. All right, let's take a pause right here and move on to another exercise in the next video. Let's take a look at another quick exercise. The goal of this one is to get a reminder on how join statements work. So in this case, we're going to join together users and orders. We're then going to print out the first name and last name of each user, and then whether or not they have paid for their order. Let's take a look at a way to approach this in a diagram format. So we're going to join users and orders together. Remember, that means that we're going to select all the rows from one of these 2 tables, and then merge in all the rows from the other table. In this case, I'm going to start off with all the rows from users, but for this particular example, we could go either way. We could start either with users or orders. It would not make a difference in this case. So we're going to take all the rows from users and imagine that we put them down in this new temporary table. Then for every single row inside of here, we're going to try to find a order with a user ID equal to an ID inside of the user back over here. So in this case, we might start off with the user with ID 1. So we go through all these rows and try to find a user ID of 1. It looks like this first row right here has it. So we'd take that first row and drop it right there. We then repeat the process. The next one is 2. So we're going to go through all these rows, find one with the user ID of 2. There they are right there. So I'll drop them in. Next one is 3. Here's the user with ID 3. Okay, that looks good. We're on to 4. We're on to 5. And then finally, 6. So now we should have identical ID and user ID inside of every single row. So I see 1, 1, 2, 2, 3, 3, 4, 4, and so on. Now, out of all these different columns, there are only 3 columns we actually care about, which is first name, last name, and paid. So we're going to want to make sure that we then select just those 3 columns. So we would basically be forgetting about all the other columns in this case. All right, so that's the general idea of what we're trying to do here. So go ahead and give the SQL a shot, and we'll take a look at a solution in just a moment. All right, let's take a look at a quick solution. So I'm going to first put down a select, but I'm going to write out the from and the join first, because again, me personally, I like to really understand the data I'm working with before I try to select any columns. So in this case, I'm going to start off with all the different rows from users. And again, you can take this approach or you can solve this problem from either perspective. You can start off with orders and join in users, or start off with users and join in orders. Totally up to you. So I'm going to start off with all the rows from users. I'm then going to join in the orders table on orders.userid equal to users.id. Now, once again, the new line that you see right here, you do not have to put in. It's being put in automatically because of this editor I'm using. So now that I've joined all this data together, I can select just the columns that I care about, which in this case is going to be the first name, the last name, and then the paid status for the order. So I will select first name, last name, and paid. Okay, let's check our solution. And how are we doing here? Yep, there we go, finally. So I see all the different first names, last names, and whether or not they paid for their order. Awesome. Well, let's move on and continue in just a minute. In this video, we're going to take a look at sorting records. So sorting records means that we're going to retrieve some number of rows from a table or some other kind of data source, and we might try to reorder all these different records based upon some value in a column. Honestly, sorting is going to be one of the easiest things we discuss around SQL. Let's just take a look at a quick example or two, and you're going to get a good idea of what's going on really quick. All right, so we're going to do a quick query over here. I want to print out all the details about all of our different products, and I want to sort them by price. So I want to go from the least expensive all the way to the most expensive. To do so, we would write out select star from products, and then we would order by. So just like group by, order by makes use of two separate keywords. Make sure there's a space in between the two. So it should be order space by. We'll then specify the column that we want to use for sorting. In this case, it's price. So I'm going to run that. And we can see very easily we've got all of our different products and they are now ordered by their price. Let's see 1, 10, 32, and it goes all the way up. By default, whenever you order by some value, you're going to go from the least value to the greatest value. If you want to flip that order, then you can apply a little optional keyword right after that sorting column. We can apply DESC, which is short for descending. That means we're going to start off with the greatest value first and then descend down to the lowest value. So if we run that, now we get the greatest prices on top. If you leave off that descending keyword, then the default is ascending order. So if we leave it off, we are ascending in value. We are going up in value. We can optionally put in ASC, short for ascending right here, but it is the default value. So you only put in ASC if you want to be really, really obvious or clear to other engineers what the sort order is for some reason. So if we run that, we get the exact same result. Honestly, that is pretty much it for sorting, at least sorting numbers. Let's take a quick pause here, regardless, and we're going to take a look at one or two variations on sorting in just a moment. There are two variations on sorting that I want to show you. Like I said, it's going to take just a moment or two. Sorting is one of the easier things that we're going to deal with. I'm going to, again, select all of our different products, but this time I'm going to sort by a value that is not a number. In this case, I want to list out all my different records based on the name. So hopefully this will take all the records and rearrange them in alphabetical order. Let's try a select star from products, and we are going to order by name. I'm then going to run that, and we'll see very easily, yep, we've got all these different rows now sorted in alphabetical order. Just like with the numbers, we can apply the DESC, which means we would start from Z and then go to A. So if I run that, I now am at the end of the alphabet, and at the very bottom are the A records. If we leave off descending, then the default is ascending, and again, we can optionally put on ASC if we just want to be really clear about what is going on. All right, so clearly we can sort by different types of values, numbers, or strings of characters. And the last thing I want to show you around order by is that we can order by multiple different properties. So let me show you what I mean. I'm going to change the order by back to ordering by price. Now, as we go through this data set, you might notice that the first 4 records here have the same price. Well, at least the first 2, and the next 2 have the same price for each other. If we want to, we can not only sort by price, but if 2 records have the same price, we can then apply a second ordering rule. So in this example, let's try to sort by price, and then if 2 records have the same price, I want to then order those 2 records by weight. To do so, we would put in order by price, and then weight. Okay, well, let's run that. And now you'll see that those top 2 records right there just flipped. So because they have the same price, we then used weight as a second sorting criteria. And we sorted them by ascending weight. So 11 first and then 21. We can apply sort order options to each of these different properties or these different column names. So if we put on DESC right here, after weight, that means we want to sort by ascending price and then descending weight. So if we run this, I would now expect to see 21 first. And if I run that, yep, there we go. Okay, so honestly, that is it for sorting. We're going to take a look at a quick example just to make sure this idea is crystal clear. but other than that, sorting, not the worst thing in the world. In this video, we're going to take a look at two new keywords, offset and limit. These are two keywords that are pretty straightforward, so we're just going to spend one video on them. I think you'll understand them rather quickly. We make use of offset anytime that we want to skip some number of records in a result set. So let's imagine that we write out a query to fetch all of our different products, all the different rows, and all the different columns. If we applied an offset of 3, that means that we would want to skip over the first 3 records, and we would only get back the remaining ones. Let's take a look at an example of offset right away. So back over here, I'm going to first take a look at the number of users in our users table. So I'm going to do a select count star from users. It looks like we have 50 users in total. Let's now try to fetch all the different rows and columns of our users table, but I only want to see the last 10 users. So to do so, we could write out select star from users, and then I would offset by 40. That means skip the first 40 users and only show us the last 10. So now if we run that query, we can see very easily we get back results starting at an ID of 41 and then going up to 50. That's pretty much it for offset. It just means skip some number of rows from our result set. Limit is somewhat similar in nature. It is going to constrain the number of records we get back from the result of a query. Limit, in particular, is going to make sure that we only take some specific number of records out of the result set. You are frequently going to see limit and offset being used together. So let's imagine what would happen if we applied a limit of 2 and an offset of 3. First, the offset of 3 means we want to skip the first 3 records. A limit of 2 means that we only want to take the first 2 rows out of the remaining results. So we would drop off all the remaining rows of 6 and 7, and we are left with just 4 and 5. We do not have to use limit with offset. We can use limit by itself. Let's take a look at using limit by itself and then try combining offset and limit together. Okay, so once again, I'll do a select star from users, and I'm going to limit 5. That should give us just the first 5 users of our users table. So I see users with ID 1 through 5. We can go all the way down to a limit of 1. We can do a limit of 50. That's how many users we have in the table, so this effectively is the same as just fetching all of our users. We can also specify a limit greater than the number of records we have, and nothing bad is going to happen. If you have fewer records than you have of the limit right here, you're not going to get an error, you're just going to receive or retrieve all the different rows that are available. All right, so let's now try applying limit and order together. I want to try to order all of my different products by price. I then want to retrieve the 5 least expensive products. So to do so, we could do a select star from products. I'm going to order by all these things by price. By default, we get an ascending order here. So if we run this just by itself, we'll see that we get all the least expensive products first. So we could then apply a limit of 5, and that will give us our 5 least expensive products. If we want to see the 5 most expensive, we could do a different sort of order here of descending. That means we'll see the most expensive products first. Yep, there we go. So there's our 5 most expensive products. If we wanted to, say, find the 5 most expensive products, except for the most expensive one, we could then apply an offset after the limit. So I'd apply offset right here of, say, 1. That means that we would skip the first row and then only take the next 5. So if I run that, now the ID of 80 is gone, and we see the next 5 after it. If you ever make use of limit and offset together, you will place the limit first and then the offset. Technically, it can work either way. You can put offset first, but by convention, we put limit first. All right, so that is it for limit and offset. Now, you might be curious, where would we ever use these? Well, there's 2 scenarios in which we would use them. First, you might use just limit by itself anytime that you want to find the top record of something, or maybe the top 5 or something like that. And we just saw an example of that. The query that we have right here, where we make use of order by, is going to give us the 5 most expensive records. If we remove the descending, then we get the 5 least expensive records. If we wanted just the least expensive record, we could do a limit of 1, and now we can see information about the least expensive record overall. That's limit by itself, but where would we use offset? Well, like I said, limit and offset are frequently used together. A very common use of limit and offset together is anytime that you're working with a large set of records that you want to display to a user. So our fake database right here has 550 different products in it. But across the world, there's companies like Amazon where they have millions of products. In some cases, there might be just too much information to show to a user on one single screen. So you might want to only show a user, say, 20 records at a time. To do so, we could apply an offset and a limit. Let's say that we want to only show a user 20 records at a time. To do so, we would apply a limit of 0, or a limit of 20, and an offset of 0. This would give us our first page of information, a first page of results to show to a user. So now a user is only seeing 20 records here, which in general is enough or small enough a data set to be parsed by a user. We could then present them with a button that allowed them to go to a next page of results. If a user ever clicked that, we could then do a follow-up query, and we can increase the offset by 20. So now we're saying skip the first 20 records and only show the next 20. So we can run this, and now we're only seeing the next 20. We can then go to an offset of 40 and continue on down. Okay, so that's pretty much it. Well, let's take a quick pause right here and go through a quick exercise in just a moment. Time for another exercise. This exercise is going to combine together sorting, offsetting, and limiting. The goal is to once again take a look at our table of phones. We want to sort by price, and we want to only show the second and the third most expensive phones. So again, you're going to have to apply a sort, offset, and limit to do so. Go ahead and give this a shot. As usual, we'll take a look at a solution in just a moment. Time for a solution. Well, we definitely know that we want to print out the name of every phone that we retrieve, so we can get started at least with a select name from phones. That much is probably clear. After that is where we are going to want to apply our sorting, offsetting, and limiting. So we're going to first get started by doing our sort step. I'm going to order by price. Now remember, by default, whenever we do an order by, we are going to get an ascending order, which means that we would have the least expensive records first. In this case, we are trying to select the most expensive phones. So it might be a little bit easier if we sort by descending value, so that we get all the most expensive phones first. So I will do a descending order like so. Then after that, we can apply a limit and say that we only want 2 rows to represent the second and third phones. So I'll do a limit of 2. And then finally, we want to skip over the very first result, the most expensive phone. So we can do an offset of 1. And that should be it. I'm going to check my solution and see how I'm doing. And after a little pause, yep, looks good. All right, well, that's that. Let's continue on in just a moment. In this video, we're going to take a look at another new keyword called union. Let's take a look at a little question, try to solve it, and understand how this new keyword is going to help us out. So our goal is to write a query that's going to find the 4 products with the highest price. And in addition to that, in addition to those 4 products, we also want to find the 4 products with the highest price to weight ratio. This is absolutely a realistic query that we might have to write at some point in time. In general, for a company, it makes a lot of sense to sell the most expensive items. We might want to get a list of the most expensive items and the items that are also the most cost efficient to ship. Again, assuming that we are paying for shipping based upon the weight of these different items. So in total, we want to find about 8 items or so. It might end up being less than 8 because some products might be the highest price and also have the highest price to weight ratio. So I want you to take a look at this right away, and I want you to kind of notice that it might be a little bit challenging to write a single query that is going to find this set of about 8 products or so. The reason for that is that to get the 4 products with the highest price, we're probably going to have to do some kind of order by operation. We're probably going to have to do sort by price, and then do a limit to just get the top 4 most expensive items. The second one, or the second part of this, the next 4 items, is going to use some very different sorting criteria. In this case, for the next 4, we want to sort by a price to weight ratio. So it's 2 very different sorting criteria, and putting these both into a single query would be rather challenging. Well, to get started, let's just try to write out a query to answer this part, and then a second query to answer that part. All right, so back over here, I'm going to do a select star from products. I'm going to order by price, descending to make sure that we look at the 4 most expensive products, and then I'll do a limit for like so. So if I run this, I can see very easily I get 4 pretty expensive looking products. That looks pretty reasonable. All right, so I'm now going to comment this out, and I'm going to write a second query that's going to answer the second part of this. So I want to get the 4 products with the highest price to weight ratio. That'd be something like a select star from products. This time around, I'm going to order by a computation. So I'm going to calculate a value and then use that to do some sorting. So I'm going to do a price divided by weight. And I'm going to use that as my sorting criteria. We're then going to order the list descending, and again, limit 4. So I'll run that, and I can see that I get a different set of results here. In this case, I even get a product with a price of $345, which is definitely a very low price, but because it weighs so little, this might be a very profitable item to ship. So we now have 2 separate queries, and we want to somehow combine the results from both of them. Well, this is where the union keyword is going to come into play. So I'm going to uncomment both these queries. I'm going to remove the semicolon on the top one. I'm then going to wrap them both with a set of parentheses. So I'm going to put one parenthesis right there, do a little bit of formatting, another one right there. So I just wrapped the first one with a set of parentheses. I'll then wrap the second one with a set of parentheses. And I'm going to remove the semicolon at the end of the second query as well. I now only have one semicolon at the very end of everything. Then finally, between these 2 sets of parentheses, I'm going to put in the union keyword. So what does union do? Well, as you might guess, it's going to take the results of one query and join it together automatically, or kind of append these 2 sets of rows together with the results of the second query. Let's now run this and see what we get. All right, there we go. So we've now got a list of the top 4 most expensive items and the list of the top 4 most cost-efficient to ship items as well. You will notice right away that there's only 7 items here, however. There's not 8, as you might expect. The reason for that is that one of these different products, who knows which one it is, we could definitely figure out, one of these products is present in both lists. If the union keyword sees an identical row in both lists, then it's only going to list that row in the output one single time. So the results of this query and this query produced an identical row in one instance, and Union decided to remove that duplicate. If we do not want Union to remove that duplicate, we can change the keyword slightly and use Union All instead. Union All means don't try to remove any duplicates. So now if we run this again, we'll see that one of our items in here, one of the products, is in fact duplicated. It looks like it is product, let's see, we got the ID wrong somewhere in here. Here it is, 7. The product 7 and 7 right there, duplicated. So if we want to see those duplicates, then we would use that all keyword on there as well. Okay, so that is pretty much it as an introduction for union. We use this to join together the results of 2 queries. If we ever do not want union to remove the duplicates, we put in union all. There are a couple of rules that you need to understand around union, so let's take a look at these rules in the next video. In this video, I want to give you a couple of different notes around the union keyword. So first, we just wrote out a query that is using some parentheses around the 2 sets of data that we are trying to join together. It is not required strictly to always use parentheses around these 2 different sets that we're trying to join. In this case, we only use the parentheses because otherwise the database might be a little bit confused on whether we are trying to apply an order by to just this query right here or to the results of the entire union. Same thing for limit as well. If we just have limit by itself, database might be confused about whether we are trying to limit the rows coming back from just this or the entire union. So if we try to run this without the parentheses on there, we might see an error like so. To solve that error, we can just put in those parentheses that we had a moment ago, and now it's super clear that we are trying to do an order by and a limit on the results of this data set right here, just the rows we got back on the from products. So you might see a union that doesn't make use of those parentheses at all, so it might end up looking something like this, maybe something like select star from products union select star from products. So if we run that, we don't have any parentheses and everything still works as expected. And the next thing I want to mention is how we join together these two different sets of data. In particular, the required structure of them. So I want to imagine for a second that we once again have our products table, and then maybe we run two separate and very different queries on it. So on the left-hand side, we are selecting the name and the price columns only from products. And so we would end up with a result that looks like this. On the right-hand side, we're selecting name and weight from products. And so we end up with a name column and a weight column. We are only allowed to use the union keyword between the results of two queries where the results have the same columns. So they must have the same name, and the data inside them must be the same type of data as well. So even if we had something like, say, how about we change this a little bit, and we had something like, how about, I'm going to change name over here to price, and I'll change weight to name. So let's just imagine for a second that for some crazy reason we got a result that looks like this. In this case, we've got the same name of columns, we have a price, and a name, but the type of data across these two results of queries is different. Over on the right-hand side, our price column has strings, but on the left-hand side, price has numbers. And likewise, on the left-hand side, name has strings. Over here, name has numbers. So we must always have the same columns, must be the name the same, and they must have compatible data types as well. We can test this out very easily by doing, say, a select name from products, and then try to find the union of that with a select price from products. And if we run that, yep, we're going to get an error like this that says, sorry, but we can't match these different types of columns together. Doesn't even matter if we also tried to do, say, rename a column. So if I tried to rename this price column over to name, we're going to see a very similar error as well. All right, so that is it for union. Now this is just one set operator. A set operator is a keyword that's going to try to join together different sets of data. In this case, we are treating our set as being the result of a query. We're going to take a look at two other types of set operators that you might need to make use of. Let's take a look at those in the next video. Besides the union keyword, there are a couple of other keywords that we use to work with multiple sets of data. Whenever I use the term multiple sets, I'm essentially saying the result of multiple different queries. So we made use of union to join together the results of two different queries, and it also removed duplicated rows. We also took a look at union all, which also meant join together the results of two queries, but that did not remove duplicate rows. In this video, we're going to focus on intersect. We make use of the intersect keyword to take a look at two different queries, and it will give us back rows that are common in the results of both of those queries. So intersect means give us rows that are common. Let's try this out. To test out intersect, we're going to first write out the same query that we wrote just a moment ago, where we found the 4 most expensive products and the 4 products with the highest price to weight ratio. So same thing we had before, just to get us started. So I'm going to put in a set of parentheses, and we'll do a select star from products, order by price, descending, and then only show us the first 4 records. Then for right now, we'll do a union once again. And then the second one will be a select star from products. We will order by price divided by weight, descending. And again, limit 4. So this is what we had just a moment ago. If we run this, we will see, once again, we get back only 7 results, even though we kind of expect to see back 8. We expect to see 8 because we asked for 4 records from the first one and 4 from the second one. Because we only see 7, that means that the union keyword must have deleted one duplicate entry here. As we saw, we could find that duplicate entry by doing a union all, and then manually looking at our result set and we can see that the ID 7 is duplicated in here. Now, if we wanted to programmatically find the rows that are duplicated or common to both these queries, instead of doing a union or a union all, we can instead do an intersect. So again, an intersect is going to show us only rows that are common to both. Now we can run this, and sure enough, we get only the row with ID 7, because only that row was common to the result of this query and this query. Now there is a variant of intersect, intersect all. Once again, that is not going to remove any duplicate records, but in this case, it's got a slightly different meaning. When we think about intersect, intersect is going to find rows that are present here and here. And so you might think that if we put on intersect all, we would expect to see row with ID 7 twice. That is not the case. Instead, we are only going to see intersect all expand this if we see row with ID 7 appear more than once here and more than once here. So if we just put on intersect all and then run that query again, we still get the same result. And it's because, again, the all in this case means that we are going to see that row multiple times, either here or there, not once here and once here. Okay, so that's intersect. So just one other keyword that we're going to discuss in the last video, except. So quick pause, and we'll take a look at that in just a moment. In this video, we're going to take a look at our last set keyword. This last one is called except. And the goal of except is to take two different queries, and it's going to give us only the rows that are present in the first query, but not the second. Now, this one has a little trick or two to it, so let's take a look at a quick diagram and really understand what except is going to do. All right, so in this diagram, we've got the result of one query on the left-hand side, and then the result of another query on the right-hand side. And we're going to apply except to the results of these two queries. So with except, we're going to take a look at every single row on the left-hand side. If that row exists on the right-hand side, we're going to remove it. Let's go through this row by row. We can start off first with row with ID 1, and we're going to see if that row exists on the right-hand side. In this case, no, it does not. That means that the row with ID 1 is going to stick around for our final result set. Next up is the row with ID 2. This one does exist on the right-hand side. So because of that, we are going to remove it from the left. Next up is 3. 3 does not exist on the right, so we're going to hold on to it. And then finally 4. 4 does exist over here, so we're going to remove it. And that's it. We're then left with our final result set, which would be just the rows with ID 1 and 3. Now there's two very important things I want you to understand around except. You'll notice that on the right-hand side, we had some extra rows right here of 5 and 6. 5 and 6 did not exist on the left hand at all, but that doesn't make a difference when we are making use of except. Except really just cares about the rows that are present on the left-hand side. The query that, or the rows we get on the right-hand side, we can get extra rows that don't exist on the left, and that will not impact the final result. So we can have tons of extra rows over here, just tons and tons and tons of extra rows that don't exist on the left-hand side, and that's not going to have any impact whatsoever. We are only taking the left and subtracting the ones out that also exist on the right. We're not finding a kind of total difference or anything like that. If we were trying to find a difference, like a true difference between these two queries, then we would include these ones on the right-hand side, but that is not what is happening here. Now, there's one other very interesting thing about the except keyword. When you really start to think about this entire process, where we are really just considering the rows on the left-hand side, you might notice that all the other keywords doesn't really make a difference the order of queries that we issue into these keywords. In other words, with union and intersect, we can show, or we could place this query on the left-hand side or the right-hand side, and it doesn't make a difference to the final result. However, the same is not true when we are making use of except. If we were to flip the order of these two queries, so notice I now have the ratio query over here on the left-hand side. If we change the order, then our final result is going to change as well. So now on the left-hand side, we have 2, 4, 5, and 6, and on the right-hand side, we have 1, 2, 3, 4. So let's take a look at the except keyword being applied to these two data sets now. We would start off with 2. That is present on both sides, so we delete it. We've got 4, which is present on both sides, so we delete it. And then we are left with just 5 and 6, which are not present on the right-hand side. And so our final result set would be just rows 5 and 6. So notice that our final result here is very different. We have 5 and 6 compared to what we did just a moment ago, where we ended up with 1 and 3. So the order of queries we feed in here is going to have an impact. Okay, so that's pretty much it for accept. Now very quickly, let's go and put together a quick example. We're going to again do this kind of order by price limit 4 and order by price divided by weight limit 4 as well. Okay, so back over here, I'm going to once again put in some parentheses. Again, parentheses not normally required. We are just putting them in because otherwise our database would be a little bit confused by those order by and limit keywords. So I'm going to put in a select star from products, order by price descending, and I'm going to limit 4. I'll then do an accept. And in the second one, we'll do our ratio. So from products, order by price divided by weight, descending. And then we will also limit 4. Okay, so let's run this and see what happens. So we get back 38, 46, and 80. So in theory, these are all rows that we got back from the first query, but not the second one. We could very easily double check that. We can comment out everything inside of here, except for the very first query, and just manually inspect the results from it. So if we do that, we end up with 38, 46, 80, and 7. So we did not see 7 when we made use of the accept keyword, which is a sign that 7 must have been present from the results of both this query and that second one as well. We can very easily verify that once again if we comment out the first query and uncomment the second one. So now when we run this, we should see some results where the only common record is 7. So I'm going to run this, and sure enough, there's a 7 right there. So because 7 was present in the results of both queries, it got removed from the overall result set. And then beyond that, we only held on to the other rows that came out of that first query. Okay, so that's it for accept. So we've now taken a look at several different set keywords that allow us to manipulate the results of multiple different queries. Let's take a pause here and go through some exercises in just a moment. Let's take a look at a quick exercise around the union keyword. In this exercise, you are going to write 2 different queries. The first one is going to print the manufacturer of all phones where the phone's price is less than $170. The second query you're going to write out is going to print the name of all manufacturers that have created more than 2 phones. You're then going to join these 2 results set together by using the union keyword. 2 important notes before you try this. First off, you do not need to wrap these 2 different queries with parentheses. In this environment, when we run our SQL, it's being executed on a different database than Postgres. And there are some very, very subtle differences between the database that is being used here and Postgres. One of which is that we can't really use any parentheses when using the union keyword. So you will not use any parentheses here. The other thing I want you to know about is that to solve the second query here, where we have to print the name of the manufacturers that have created more than 2 phones, you can do that by using a group by statement, and then apply a having filter on each of those individual groups. So you want to apply having and probably find only the groups where there are 2 rows inside there, or I should say greater than 2 rows inside of each of those groups. So go ahead and give this a shot, and we'll take a look at a solution together in just a moment. Let's take a look at a quick solution. So we're going to write out those 2 queries and then join the results together by using the union keyword. I'm going to first get started by finding the names of manufacturers of phones where the phone's price is less than $170. So for that, we can do a select manufacturer from phones where the price is less than $170. I'm then going to take all those rows and join them together with the results of another query by using the union keyword. So then our second query, we're going to once again select manufacturer from phones, but this time we're going to do a group by. We're going to group by the different manufacturers, and then we're going to apply a filter to those different groups by using that having keyword that we discussed a while ago. So we'll put in a having, and we want to find only the groups that have greater than 2 rows. And we can do that with a count star greater than 2 like so. And that should be it. Let's check our solution and see how we're doing. Now, I want you to note that this exercise here, if you had any trouble with it, totally fine. The real challenge was actually writing out the second query as opposed to making use of the union keyword or anything like that. Okay, looks like we got a good solution. Okay, quick pause here and continue in just a moment.